Hello chemists, this is Ms. Blachino and you are watching Screencast 1.2 on the classification of matter. During this tutorial we're going to work on differentiating between different types of matter, namely compounds, elements, and mixtures. Let's take a look at the do now. We're told that air consists of N2, O2, AR, and CO2. Classify air and the components of air as compounds, elements, or mixtures. Alright, so I'm going to start with AR because I think that's probably the easiest one to explain. If you look at your periodic table, AR is element number 18. It's argon. It's a monatomic element, and we've used the word a couple times now. Argon is definitely an element. If you can find it on the periodic table, it's going to be an element. Up next, I want to look at CO2. CO2 is carbon dioxide, and as the formula suggests, we've got two different types of atoms present. We've got carbon and oxygen, specifically one carbon atom and two oxygen atoms, represented by this model. The black atom is carbon, the two red atoms are oxygen. So it looks like this is going to be a compound. When you get to N2 and O2, those tend to be a little bit more confusing for students. So let's pull up pictures of what these two molecules would look like. O2 is the red molecule, and N2 is the blue molecule. Now some students feel that this must be a compound because you've got two elements combined. It's not just N or O, for example. You've got two nitrogens and two oxygens. Other students make the argument that no, this has to be an element because you've got two of the same atoms bonded together. And it turns out that students that make that argument are correct. These are known as diatomic elements, sometimes called diatomic molecules. Don't be fooled. Even though there are more than one atom present, both of these, N2 and O2, would get classified as elements. We're going to be looking at particle diagrams during this tutorial and going through a number of examples to hopefully get you more comfortable with classifying matter. Alright, so we'll talk about the basics. First off, when we say matter, we're just referring to anything that has a mass and volume. So that gives us plenty of things to study. We talked about the different phases of matter yesterday. We're going to be focusing on solids, liquids, and gases. We'll leave plasma and the likes for physicists to study. And the atom is the simplest building block of matter that still retains the properties of the original substance. For those of you who know a little bit more about the structure of the atom, you probably know that it's made up of protons, neutrons, and electrons. We say that the atom is the simplest building block of matter because if you take an atom and you break it into protons, neutrons, and electrons, it loses the chemical and physical properties the original substance once had. So no, atoms are not the smallest thing on the entire universe by any stretch, but they are the smallest piece of matter that still retains the properties of the original substance. We can take matter and break it into two categories, the first of which is pure substances. Pure substances have fixed compositions and well-defined chemical and physical properties. If you're not sure what chemical and physical properties are, go back to Screencast 1.1 where we address that concept. Pure substances can be classified as either elements, which consists of one type of atom. Remember, something like N2 and O2, even though they're two atoms combined, it's just one sort of atom, making that that sample an element. And they cannot be broken down by chemical means. So for example, if you've got hydrogen, sorry, that's a sloppy looking H, you can't break it down into like a proton plus an electron. That just does not happen. So that's why they're our simplest building blocks of matter, just to reiterate from the last slide. The other type of pure substance are compounds. Compounds consist of two or more different elements that are chemically combined. They can be broken down by chemical means. So for example, we know that water is H2O. Based on that formula, hopefully you recognize that this is a compound. We have two different type of elements that are bonded together. And I can take water molecules and using electricity, I can break it down into hydrogen and oxygen. Just get that balanced. So that's what we mean when we say it can be broken down by chemical means. Basically, you can run some sort of reaction and you can break the compound into its original elements. If it's not a pure substance, you have a mixture. Mixtures consist of two or more substances that are physically combined. And what we mean when we say physically combined is that the atoms or the molecules of the sample are in physical contact with one another, but they're not interacting. They haven't exchanged electrons or shared electrons. They haven't formed a new substance. They just happen to be in the same proximity. Mixtures do not have a definite composition or well-defined properties. We can classify mixtures as either homogeneous, meaning the same throughout or very uniform, or heterogeneous. You have visibly distinguishable parts. A good example of a homogeneous mixture, or homogeneous, doesn't really matter which way you say it, is milk. If you look at your container of milk at home, it probably will say pasteurized, homogenized. Basically, that just means is that it's the same throughout. Milk is a mixture. It has things like sugars, fats, water, proteins. You don't ever have to worry about that coming apart or separating. It's homogeneous, the same throughout. Compare that to something like sand and water. That's going to be a heterogeneous mixture. Sand is going to sink to the bottom of the container. The water will float on top, and you've got really that line between the two different substances. All right, I want to look at some particle diagrams and see if we can identify them as compounds, elements, homogeneous or heterogeneous mixtures. This is our first one. Hopefully by looking at this right off the bat, you recognize that this is an element. There's only one type of atom present. More specifically, these are monatomic. This is a monatomic element. The prefix mon meaning one. Let's look at another one. Hopefully you recognize that this is a compound. Sometimes you're going to hear people call compounds molecules. We're going to use them basically interchangeably throughout the course, so don't get too hung up on the details. We're talking compound. We've got two different types of elements represented by this purple sphere and this pink sphere, and when they're in contact like that, we usually assume that they've been chemically combined. All right, again, this is the one that usually gives people trouble with classifying matter. Is this a compound or an element? Well, hopefully you recognize that this looks strikingly similar to N2 and O2, which we talked about at the beginning of this lesson, and it is a diatomic element, sometimes called a diatomic molecule. It's worth kind of making note of the 7 diatomics: hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. That might seem like a lot to remember, but if you look at a periodic table, all these guys are in the same vertical column, column 17. Oxygen and nitrogen are right next door, and then you've got hydrogen kind of on its own on the other side of the table. And as you learn more about the periodic table, you'll see that hydrogen is kind of just in a bad spot. There's no good place for it. These elements will never exist as a single atom. For example, we'll go back to that reaction where we're going to take water and break it back down into hydrogen and oxygen. We're never going to see this. We can't have that oxygen atom all by itself. It's diatomic. It will never just be oxygen. It would have to be O2. And then for those of you who know how to balance already, we've got to put coefficients in front of water and hydrogen. So just something to kind of tuck away. It's going to make more sense and be more important when we start writing reactions. Those are the 7 diatomics. You will never, ever, ever see them as a single atom in this course. All right, our next particle diagram. Hopefully it jumps out at you right away that we have multiple substances present. So this has to be some sort of a mixture. If you look, we can really just kind of draw a line that separates the green monatomic elements from the blue diatomic elements. Since they are in 2 very different parts, you can classify this as a heterogeneous mixture. You can kind of imagine shaking up that little particle diagram box and maybe getting something that looks a little bit more like this, where they're kind of evenly distributed. It's fairly uniform, the same throughout. Hopefully you can recognize that this is a homogeneous mixture. And it's worth noting that all gases are homogeneous mixtures. For example, you don't have to worry about sitting in class and all of a sudden all of the oxygen molecules rush to the opposite side of the classroom from where you're sitting. It's not going to happen. Gases by their very nature are going to stay mixed and they're going to be homogeneous. Let's work on some practice problems. Okay, so if you look at page 7 in your notebook or your workbook, you've got some practice problems. I want to start with this group first. Let's look at questions 1 through 6. I want you to classify each of these as an element, a compound, or a mixture. If it is a mixture, try to determine whether it's going to be heterogeneous or homogeneous. So go ahead, pause the video, get these figured out. All right, so let's take a look at zinc. If you look at your periodic table, zinc is present there. It is an element. Again, if it's on the periodic table, kind of a dead giveaway that it is an element. Number 2, copper wire. Don't let the fact that this is a wire fool you. It's still just a pure substance, namely an element. Copper, again, on the periodic table, it is an element. Brass, we talked a little bit about yesterday. Brass is an alloy, and if you recall, alloys are 2 metals that have been melted down, physically combined, and cooled. Since it's just a physical combination of two different pure substances, this is definitely going to be a mixture, not a compound. Because it's more or less the same throughout, we would classify this as a homogeneous mixture. Oil and vinegar, maybe something like a salad dressing, also a mixture. You could probably make an argument for homogeneous or heterogeneous. If you just shake it up right away, immediately it may look fairly homogeneous, but if you give it a chance to settle, the oil and the vinegar will separate out due to differences in polarity and density, two topics that we'll cover a little bit later, and it's going to look heterogeneous. Number 5, water. We talked about that as an example. Water is a compound, H2O. Carbon dioxide, talked about that as an example as well, CO2, another compound. I would recommend trying out 7 through 18 on your own and checking the answer key online. Let's go ahead and look at some of the particle diagrams. So question 19, classify each particle diagram as an element, a compound, a mixture of elements, a mixture of compounds, or a mixture of a compound and an element. And let's just work on that first row. So pause the video, try them out, and we'll go through them together. All right, so if we look at letter A, particle diagram box, hopefully it's very clear to see have different types of matter present. I see this and I see that. And there are a whole bunch of them in there. They look like they're pretty well distributed. So I would classify A as a mixture of, and I'll be specific, 2 compounds. And I'm going to use abbreviations just to save a little bit of time. Moving on to question B. I've just got one type of atom. It's all the same. Hopefully you recognize that this is an element. Go over to box C. All right, I see multiple types of atoms that are bonded together, but they seem to be bonded in the same manner. We've got those 2 little white atoms bonded together and then 2 black atoms bonded onto each of the white atoms. Those are the same. This looks to be another pure substance, but this is a compound. And finally, question D. Lots of stuff going on in here. I see many different types of compounds. I've got this type, and I've got that one. Look carefully. Those 2 are not the same. And there's the 4th type. So I've got a bunch of different elements present, 4 of them more specifically. A bunch of different compounds present, 4 different types. This looks like it's going to be a mixture of 4 compounds. And that's it. Again, try out the rest for practice. Make sure we get comfortable with these. We'll be using particle diagrams throughout this semester. Okay, again, if you look at page 7 in your notes, 60-second summary is a little different. You've got something called a matter tree. Based on today's lesson, hopefully you know that we can break matter into 2 different categories, and from there break each of these categories down into 2 more. So take a moment, fill it out, and make sure that you are able to justify your answers. Keep working on the practice problems. Don't forget to check your work. And finally, if you look back at page 6, there is a demonstration that we did in class regarding iron and sulfur. I'm not going to recreate that here. There are plenty of videos on YouTube that you can watch instead. If you're interested in watching and filling out that section of your notes, go back to the course website and there's a link to the video there.